Good evening, everyone. Welcome to the class.
Good evening, sir.
Good evening, Harsim. How are you?
All good, sir. What about you?
Likewise, to know about you. Very good evening, Nukul. Welcome to the class.
Good evening, sir.
Welcome, everyone. Very good evening. Can everybody hear me properly? Let's all settle down. What are you going to do, students? You're going to go through the notes from previous session. If you have attended any previous session, you will revise, you will ask doubts, you will discuss. We have Manan, Nandini, Achal, Mohammed Azam, and Hardik as well. Welcome everyone to the class. How are we doing today? Achal, Mohammed Azam, all good? Nandini, Hardik, Manan. No response, students.
All good, sir.
How is my readability, Nukul?
Radio 5.
5, right? Okay, good. Sometimes by default, another mic on the computer gets activated, and because of which the readability goes to 3. And 3 is not good. Yeah. I am great, everyone. Mohammed Azam, this is the device you're joining from, right? No other device, right? Nandini, I heard you. Very low, but I heard you. Yes. Nice to know. But I didn't hear everything that you said. But yeah, I could hear you.
I had some technical issues, so that I have rejoined the session.
Sorry, what?
I had some technical issues, so that I rejoined the session. I left that.
Oh, okay, good. Good, no problem. Okay, students, we are learning about gyroscopes, right? It's been like, I think 2 sessions that we have introduced gyroscopes, and we are talking about gyroscopes. Harsim and Hardik and Achal, do you have basic idea what are gyroscopes? And I remember, students, I had shared, what do we call it? I had shared my handwritten notes on rigidity and precession for y'all. As well, I think I had shared a textbook also, Oxford-based textbook, PDF for one introduction chapter of gyro. Am I right, Nukul? Mohammed Azam? Yes? Did you all read? Did you all read? Did you get a chance to read? Harsim, Hardik, response?
Yes, sir. It was the notes which you were explaining in class. It was the written notes of that.
Yeah, it's same, my words only.
Yeah.
Hardik and Harsim, how about you? Did you get a chance to go through that?
Sir, not like I have not read all the pages, but a few.
Okay, no problem, no problem. What about you, Harsim? Did you get a chance to go through the previous lectures, read the text, anything?
No, sir. I have not attended the previous lecture. Actually, I was revising
No problem.
RT lectures.
No problem, no problem.
बंद कर दे.
See, for Hardik and Harsim and for Achal, okay. Nandini, apparent wonder, real wonder, yeah, don't read all that. I'll explain that in class, but keep the textbook. Now or then it will help. It will be helpful. Yeah, for Hardik, Achal, and Harsim, these classes are just extra for you, okay? Just extra to keep you occupied and to keep you a step ahead, okay? So whatever you can learn will be helpful to you in future. So just push yourself and make the best out of it. Okay, it's not my intent to make you join a batch in between because the other students are almost done. They are on the verge of completing. So that mixture will never happen if you're worried about it. It's just that learning with them, because we are learning fresh topics, you'll be one step ahead when your training starts. So when your training starts, you'll already have basic idea about gyros. So you'll be like one topic is already there, basic covered. So that's the idea. Okay. Subhajit, welcome to the class. Nice to see you, Subhajit. Nukul,
Good evening,
Mohammed
sir.
Azam, Subhajit, how are you?
I'm doing good, sir.
Good evening. Good, good. Did you get a chance to go through the notes I had shared?
No, sir, not really. I didn't get
No
any
problem.
time.
No problem. Take it easy. We have a lot of time. Don't worry. Even if you attend the lectures, it's fine for gyros. Anything that I'm giving you for gyros is only extra further reading, which you can read even after we complete gyros in class. After that, also you can do the reading part. Not a problem. Okay. Right. So today we are going to talk about the most important parts of this topic that we have for you. What are the most important parts? Understanding rigidity and precession. Okay. All right, everyone. Mohammed Azam? Yes? No? I think Mohammed Azam has network issues again. He's frozen. Nukul, you can hear me, right? Yeah, Mohammed Azam, there, right? You can hear me, right? Yeah, good. So, what is rigidity? What is rigidity, students? Rigidity is the ability of the gyro to maintain its orientation fixed in space. What is that orientation? That orientation is of the axis of the spin of the gyro. So if I say this is a gyro rotor, now in aircraft, we have gyros that look like this, drum type. Okay. They are not disc type, but drum type. And this becomes the axis of spin. And this is a horizontal gyro because the axis is horizontal. This is the rotor. There are two types of gyros. Two types as in, how do you power the gyros? How do you get this RPM? Why do we need the RPM? If you go back to your notes, the first line that we had written down is any spinning object possesses gyroscopic properties. Okay, any spinning object. If you take a rotor and you make a shaft like this, on the shaft, the rotor is free to move. And if you give some sort of drive to the rotor to help it achieve a high RPM, then that rotor can be utilized as a gyroscopic instrument or at the core of the gyroscopic instrument. Now, Viral is not there today. Let me just check with Viral. Viral had shared a video with me soon after the lecture. In that video, one of the person who has that channel, aviation channel, they have, what do we say? Overhauled the gyro, artificial horizon. And it's a very simple mechanism. You can actually see the rotor. The rotor looks like the drum that I'm showing you right now. Okay, so I will share that. Anybody who wants to see it, let me know. I'll share the link with you all on WhatsApp. It's a short video. You can just see how they look like from the inside. Okay. 1 second. So how is this rotor given power? The rotor has such wedges. Okay. Like this. On those wedges, you can put a air pressure or suction. So mostly gyros are powered by air pressure or by suction. So the suction is provided to the gyros through different generators of pneumatic power generators, and the drive is taken from the engines only. Okay, so you need to give the gyro system some time before you can use them. The erection time or stability time, 10 to 15 minutes generally for some aircraft. It depends from aircraft to aircraft. Advanced type of gyros will not use suction, but they will use electrical motors. So they are powered by electrical power. They will have motors moving at a very high RPM. What is the range of RPM, students? The notes were given to you. The range of RPM is how much? 4,000 revolutions per minute to 55,000 revolutions per minute. The RPM, I won't say revolution, it's rotations, okay? 4,000 RPM to 55,000 rotations per minute. If you can spin a rotor this fast, that rotor will exhibit gyroscopic properties. What gyroscopic property? Rigidity. Okay, it is rigidity that we need. Jyotsna, welcome to the class. Good evening. Can you hear me properly?
Good evening, sir. Video 5, strength 5, Victor Tango, Juliet Yankee Oscar.
Good, good. Good to have you in class. Jyotsna, were you able to read the notes that I had shared?
Sir, of navigation?
Sorry, for navigation, yeah.
No, sir, not yet.
This is your first lecture, Jyotsna?
This is my first lecture. And
Have
I
you
have not,
attended recordings, any recordings before for this series of lectures?
sir, for this batch, I have started uh, these lectures of 1 to 3rd, till 3rd lectures I have completed.
No, for navigation, have you seen lecture 46?
No,
Have
sir,
I shared?
not.
No problem. Today, we are learning about gyros. Learn as much as you can, okay? Write down
Okay.
your doubts. This is just extra for you. Okay, fine. So, what we were talking about, students, we are talking about rigidity. What is this rigidity? We need to understand clearly, okay? By definition, it's okay, but what is the actual meaning of rigidity? So this is the rotor, okay? The rotor can either be powered by air pressure or suction, and otherwise through electrical motors. More advanced type of gyros are based upon laser techniques, ring laser gyros. They don't have any moving object. They just have lasers and optics and lasers. So they digitally simulate or digitally recreate gyroscopic properties. Okay, but that is beyond the scope of our CPL studies. In your CPL studies, air, suction gyros and electrical gyros will only be there. Okay. There are a lot of things associated with gyros. So we have to approach them step by step, step by step, step by step. But no matter what, every gyro will have one rotor. Okay, not many rotors. But if you have to give freedom of movement to the instrument to check different things that you want to check, like pitch angle, roll, bank angle, turn, then you need to give it freedom of movement. Now, I cannot just have this rotor openly in space, right? I have to attach it into the instrument casing, and I have to make some attachments to make a complete housing and a complete instrument. So what happens is this rotor will be attached to something like this. Okay. And that thing will be attached to an outer ring like this. So I'll make this other one in blue. They all will be hinged at one or the other point. And the blue one here is hinged here. So the blue one is called inner gimbal or gimbal. The green one is called outer gimbal or gimbal. And then the outer gimbal or gimbal, however you call it, will be attached to what is known as a frame. Okay. The frame, the rotor, the inner gimbal, and the outer gimbal. Such will be an arrangement for your any gyroscopic instruments. Now, depending upon inner gimbal and outer gimbal, this type of instrument can give me two indications, roll and pitch both. Okay. So you need to know that if there is one gimbal, then you only get one indication, depending upon whether your instrument is vertical gyro or horizontal gyro. So they are called gimbal rings because they are giving you that stability or rigidity that we require. I'll show you actual pictures. It will be easy to look at the frame, inner gimbal and outer gimbal. But what is this rigidity? The moment I start rotating my rotor at a high RPM, the rotor will maintain its axis in the fixed direction. For example, please assume this rotor, it's a disc type rotor. In aircraft, you have drum type motors. Why drum type motors? Because such a rotor will give you increased rigidity. Today we'll talk about the factors of rigidity also. So imagine this rotor is moving at a very high RPM. If it is moving at a high RPM, and if I have kept it like this in the housing or in the casing like this, then no matter what happens around me, this will remain like this only, straight. If I move like that, it will remain straight. No matter what happens, see, if I go there, it will remain straight. If I go here, it will remain straight. This is the meaning of rigidity. Keeping the axis of rotation fixed to a point, any point in space. Some people call it a star, a distant star. Those words. So this axis is maintained constantly. This is the erection time you need. Your gyros will not work when the aircraft is off. Your gyros will start working when the aircraft is turned on, when the engines are turned on. Either the APUs will power your gyros or your engines will power your gyros, depends upon how the aircraft is built. But we need this rigidity. This rigidity is aligned with the aircraft in such a way that it shows us a fixed aircraft, and the background will show us whether the aircraft has a pitch up or a pitch down attitude, roll right or a roll left attitude on an artificial horizon. And on a turn coordinator, the aircraft will bend on a turn coordinator. So something or the other will be fixed and the something or the other will be moving. So in artificial horizon, the aircraft is fixed, the background moves, the turn coordinator, the aircraft moves along with the one gimbal that it has. Okay. You have to break down your understanding of gyro in these simple terms only. The Oxford language is a little complicated. We don't need to, worry that much about it, but you do read it once or twice. Now what happens? This rigidity is good. I need it. I also use it for directional gyro indicator, gyro compass, to reduce my compass errors. But any error in this rigidity, because of precession. So precession is opposite to rigidity. If I apply a force onto this here on the axis, this is called torque in gyros. This force will act on the disc because everything is fixed. This force here will act on the disc here. And if the disc is moving in this direction, the force will act at 90 degrees of the rotation and will bend the disc and will bend the axis of rotation also. I don't need this bend. I needed rigidity. I needed the axis to point right to you. But because of this torque, I have got this. This type of error is known as drift. And errors in gyro are called as wanders. Wander. W-A-N-D-E-R. Wander is error. Simple. There are two types of wander. Drift and topple. Drift is this. Just like you're heading, crosswind coming in, and your aircraft crabbing like this. Remember, students, general navigation students, what is drift? Drift is you are supposed to be here, but you are here. So there is an angular difference between where you are supposed to be and where you are. That is drift. So horizontal gyros will drift. What type of wander? Drift. Horizontal gyros can also topple. What is topple? Horizontal falling down completely. Like if this is horizontal gyro, the torque is such that it becomes like this. This is topple. Completely shifted from its horizontal orientation. So topple and drift are the two types of wander. Wander means error. for horizontal gyros. And for vertical gyro looks like this. The axis is fixed to a distant star in space like this. If I apply torque like this here, the torque will be affecting the disc here and it will move like this. So this is topple. Falling down is toppling. Vertical gyros can only topple. They cannot drift. They will only topple like this. A basic example is that spinning top that we play with. The spinning top has a vertical axis. The spinning top is a vertical axis gyro, while your bicycle wheels are horizontal axis gyro. Are you following? So your aircraft falls, right? A horizontal gyro, not aircraft, sorry, your bicycle can fall, right? Like this or like this. That is topple. And the cycle skidding is drift. You can imagine like that. And tops, they topple. They just fall down. They don't drift. In our next class, I'll bring a top and I'll show you rigidity. I'll try to show it to you in my hand. There was one time I was trying to demonstrate using the traditional rope and top in a classroom, and I'm not good at it. So it took me around 4 to 5 efforts to make the top running. Then there was a task to take it in hand and show it to everyone that even if I'm bending my hand like this or like this, the top is still straight. It maintains its rigidity for some time. So that is a very good example to show whether the aircraft goes left or the aircraft goes right. Okay. What you will see in the demonstration is just like this. Aircraft goes left or aircraft goes right, the rigidity is maintained. The axis of rotation is maintained. So a vertical axis gyro, aircraft going like this or like this, rigidity is maintained. Like this. Simple. Like this. See, if this is the plane, and this is a gyro inside in the plane, no matter what, it will stay the same. That is the effect of rigidity. So let's write down what is rigidity, everyone. Okay. And what is rigidity based upon? Any questions before I give you the notes? Anybody wants to say, share anything, your experiences with gyros? All right. We'll write in points. Rigidity talks about gyro staying rigid. Okay. That is fixed in its present rotating orientation. Keeping the axis of rotation fixed in one direction, or as widely said, fixed to a point in space, provided no external force affects the rotation of the rotor. Read the definition again, students. Write down rigidity is equal to, or write down rigidity is directly proportional to I and R, where I is equal to moment of inertia and R is equal to radius of rotor. Don't say radius, write RPM, okay? Radius will be under moment of inertia, right? R is RPM of rotor. Don't make the confusion. I is RPM of rotor. Now, what is moment of inertia? I is the measure of how big and how heavy is the rotor of the gyro. Moment of inertia, I, is the measure of how big and how heavy the rotor is. Big comes with radius. Big comes with radius or diameter. The diameter should be high or the radius should be high, meaning is the same. Heavy mass of rotor should be high. But students, in aircraft, the most important aspect during design consideration of any equipment is weight. We cannot take heavy things in the aircraft. So any instrument that is designed for an aircraft, the first priority is reduction in weight. So how do I increase my moment of inertia to guarantee rigidity? I cannot increase weight beyond a certain point. So what I do, I distribute the weight around the periphery of the rotor. Okay. So what do? I distribute the weight around the periphery, the sides of the rotor. So the inside of the rotor is hollow and it is very lightweight, while the periphery, the outside, the circumference of the rotor, okay, is given the major mass. Just like the bicycle wheels of a cycle. The wheels have spokes, right? Small spokes, wires. In the center is axle, right? Something like this. Such spokes, right? You only have spokes and then you have the tire. Why? The mass is maintained at the circumference or the periphery to increase rigidity or to increase the moment of inertia. The same application is given to your gyros also, the rotors of gyros also. Okay. Write down. Next point. Gyros with greater mass, right under moment of inertia only. Gyros with greater mass have greater moment of inertia and thus greater rigidity. Mass of rotor, next point write down, mass of rotor needs to be kept minimum, and thus it is so achieved by concentrating majority of the mass of rotor at its rim, RIM rim, bracket right circumference. Okay, students, remember what is a rim? So now you know why wheels are designed the way they are in your bikes and your cars and your scooters, to increase rigidity only. Yes, Subhajit?
Sir, is it due to this weight constraint that you were saying optical type of rotors are introduced, or that reason is something else?
Sorry, say again, Subhajit, read you too.
Sir, is it due to this weight constraint thing only that those optical kind of rotors were introduced, or the reason for introducing those is something else?
Of course, the weight is reduced tremendously, but they are very expensive, very expensive. Okay, not everybody can afford. But these gyros, mechanical gyros, have a lot of errors and they have a lot of limitations. One of the most common errors is gimbal lock. All the gimbal rings, they all will align in the same plane and the gyro will not function. So these gyros come with a lot of limitations, physical limitations. So our optical gyros, they don't have those limitations. Simple as that. They're more advanced. But only sophisticated aircrafts can afford them. Not all aircrafts have those. And yeah, that's the only reason why we have them. These gyros are also good, not bad. What we already use. I think the ones in Airbus and Boeing, I think they're electrical motor type now. I think so. I have personally seen electrical motor type of gyros long ago, like in a shop, maintenance shop, of course. What pneumatic gyros are much more simpler in construction. Whoever designed it was a big genius because there's no electricity, only pneumatic power, and still we are achieving rigidity at a very high level. So, you know why we need to keep the weight less. After the session, please read the handwritten notes that I had shared with you. You will understand everything that is there in today's session, okay? Write down. Okay, mass we wrote. Next point, fourth point, write down. No. We need radius only, right? Next point in inertia, write down radius. Larger the radius of rotor, greater is the moment of inertia and thus high rigidity. Remember why I'm giving you like this is because questions could come with respect to moment of inertia also in the examination. So moment of inertia is increased by radius and weight. Okay. Radius and mass, I. And RPM is different. R is RPM, not radius. Okay. You saw earlier, I was also making that mistake. It's a common mistake that happens. Trust me. We need to have that clarity. So this is only the I. Now we have to talk about R also, that is RPM. Got it? So in I, we have mass and we have radius, both of the rotor. Okay. Because in aircraft, we cannot increase the radius. We have drum type rotors. They are the best rotors then. Simple. Number 4, let's write down about RPM. RPM of rotor. Sometimes instead of rotor, you will find gyro written down. It's okay. It's one and the same. This rotor is the gyro. Simple as that. RPM of rotor. Rotations made by rotor about its axis in 1 minute. With high RPM, we get high rigidity. Write down next point. Rigidity of gyro increases. Point number 1. With increased effective radius at which mass operates. Remember, these are technical words that come in the examination. Rigidity of the gyro increases with increased radius at which the mass operates. Next point, write down. With increased rotor mass. And number 3, with increased rotor RPM. Remember these points, okay? These are directly like your questions only. It looks easy. It is easy, but it is important also. Right? Next point about rigidity 6. Rigidity is also called as gyroscopic inertia. Very important point. Do not be clueless about this point if anybody ever talks about this. What is gyroscopic inertia? Rigidity. I need rigidity. So I'm not giving you the definition here, but the definition is in the handwritten notes that I've shared. Whoever has not got it, let me know. I'll email it to you also. Handwritten notes on this topic. The definition of rigidity goes by this. Rigidity is the gyro property of maintaining its axis in a fixed direction in space unless subjected to an external force. Okay. I'm not giving it to you in writing now. You have to read. It is important. You have to read. Now write this cryptic and tricky point. Rigidity is obtained by, write down number 1, one gimbal system or gimbal system. In bracket, you will write pitch and bank. Number 2, you will write two gimbal system pitch and bank plus yaw. Everybody knows what is pitch, bank, and yaw. Jyotsna, do you know what is pitch, bank, and yaw? Victor Tango, Juliet, Yankee, Oscar. Okay, so this is the aircraft. This is the horizontal. The aircraft is straight and level right now. The aircraft nose up is called pitch up, and the aircraft nose down is called pitch down. Pitch up, pitch down. This is pitch. What is bank? The aircraft is straight and horizontal right now. This is bank towards the right, bank towards the left. Bank right, bank left. Okay. And what is yaw? The aircraft is like this. The aircraft just turning like this or like this is yaw. Yaw to the right, yaw to the left. Pitch, bank, and yaw are three motions, and the only three motions the aircraft can make. All right. Bank is also called as roll. This is also called as roll. Roll. Gyros are used to indicate these only. Gyro systems are used to indicate pitch angle up and down up to 20 degrees, roll angle up to 85 degrees, and turning and turns. Simple as that. 1 degree turn or 2 degree turn, whichever turn you have. Yeah. With yaw, when we talk about yaw, write one more time. Yaw gyro uses suspension systems in the gimbal or gimbal. Attached to the aircraft. These gimbal rings are free to move, okay? The rotor, inner gimbal, outer gimbal, they are free to move. And they are attached to the aircraft by a frame, remember. So inside the frame, your gimbals will be free to move as per their design, horizontally or laterally to show you whatever indications. What is fixed is the frame. Remember that. One rotor will have one gimbal. Outside that, there will be another gimbal, two gimbals only. There are never three gimbals, two gimbals only. One gimbal is good enough to give me pitch and bank, and two gimbals will also give me pitch, bank plus yaw, like that. And together, the whole gimbal system is attached to the aircraft by a frame. Remember that, a frame. So the systems, whenever the aircraft is rolling like this or like this, the frame of the instrument is also rolling, but the gyro maintains its rigidity. Are you following, students? Everyone? Achal, Nandini, Subhajit, Hardik, Manan, Jyotsna, Harsim. How many students? Bouncer? Anyone? Bouncer? Nukul, Harsim?
Negative, sir.
Harsim? There? Following a little bit? Sorry, say again. Yeah, okay, fine. Bouncer, you are saying yes to bouncer? I hope you are a good cricket player then. Hit your bouncers for sixes. Let's talk about precession. Generally, students think that precession is very difficult to understand, but it is not, okay? Take as much time as you need, but trust me, it's easy. You can take time to study and make it easy for you, but it is easy. Write down. Precession, opposite of rigidity. First thing. Second point, gyro with high rigidity has low precession? Gyro that precesses a lot has less rigidity. How does precession happen? It's a very simple concept. One sentence answer. How does precession happen? Precession happens when a force called torque is applied to the spin axis of the gyro. In bracket, I'm writing gyro rotor. Remember, these are simple points, but they carry huge weightage with respect to your examination. How does precession happen? When torque is applied to the spin axis of the gyro. Only one possibility of precession happening. This is the spin axis of the gyro. Torque is, this is torque applied. But when this is applied like this, students, this is not the deviation that the gyro will have. The torque will be induced not like this, but from here it will go here. From here, direction of rotation 90 degrees, and then it will pull it like this. Following everyone? That's how torque acts. Otherwise, we would think that this is how the drift would happen, right? Drift or topple. But this gyro right now will not topple. This is topple for horizontal gyro, going up like this. It will not topple because precession is acting like this, but this is not how precession affects. Precession will affect torque acting here on the rotor, 90 degrees in the direction of rotation, then push like this. So it will drift, it will not topple. Are you following how, everyone? The rotation is towards your side. Like if I have to show you like this, and let's say rotation is going that side, so torque applied. So from here, the torque will directly go here. Okay, because everything is fixed, it will go here. It is rotating 90 degrees this side, 90 degrees here. This is where the torque will act. And here they will push and drift my axis away from the fixed point towards you. Got it, everyone? Harsim, Hardik, how torque works and how precession acts? Achal, Jyotsna, Nandini. Manan. Jyotsna, how about you? Are you following? So, half, 10%, 50-50. Let me know in chat box. Write down. Point number 4 only. This torque leads to change the direction which was fixed due rigidity by bringing a shift in the axis of rotor from its original rigid position. Okay.
So I have a doubt.
Yes.
So you said 90-degree, right? So it will be like clockwise itself or anti-clockwise also it will be 90 degree.
Direction of rotation. If the direction of rotation is clockwise, then clockwise. If direction of rotation is anti-clockwise, then
Then
anti-clockwise.
anti-clockwise.
Direction of rotation only. Okay. In your notes, I have given you step-by-step drawing. Okay. Step number 1, step number 2, step number 3, step number 4, step number 5. The PDF that I've shared with you, it's easy to understand the same thing that I've explained. Okay. So how it works, make sure you study from the notes there. I have explained it. It's as simple as that. How? I'll show again. Horizontal axis. Let's consider vertical axis. Okay. Let's consider the rotation to be your side. Okay. Your side. Okay. Your side. I made an arrow. I'm not sure if you can see it. Your side. Yeah. Like this. Like this. That side. That side. Left. My left. So this is rotating at a high RPM. This is the axis of rotation. I'm applying a torque. Okay, here. So this torque will act here on the disc. From here, 90-degree direction of rotation here towards me. And here it will bend like this towards me then. Samajh aa raha hai? Is it understandable, students? Let's say it is rotating in that side. And the torque is applied here. So if the torque is applied here, on the disc, the torque will act here. And because of rotation, it will again go that side. So see, two different sides, the torque was applied to different rotations. You're toppling this side. Okay. Remember that 90-degree thing about torque. Fifth point, right? Precession acts 90 degrees after torque acts and in the direction of rotation of rotor. And remember, precession displaces the axis, the rigidity of the axis. Remember. Jyotsna, the example was such that if it is rotating on that side, and if I'm applying torque here, the torque would apply here, and because it's rotating here, it will bend towards me. And the other example was opposite of it. The torque was coming from here, applied here, and it was rotating that side, so it was bending towards me. Like this. If I apply the torque, if the rotation is this side only, the earlier rotation, and if the torque is applied this side, here, so the torque will apply here, and because it's rotating in that direction, it will bend towards you in the direction of rotation. You will understand it, Jyotsna. Jyotsna, for you and for every new student, okay, I would recommend you all go through 46 and 45. If you have not gone through 46 and 45, we are starting gyros from scratch only. Anyway, you don't need any prerequisite navigation knowledge for that. Okay, do that over the weekend. You have time, right? Do that. It will keep you a step ahead in your navigation studies. If you can do that, great. If not, no problem. You have nothing to lose. Next week, we'll be starting your fresh batch, your first lectures for navigation. So then you won't have to attend with them. Otherwise, I'll suggest you all to attend, then you attend. Okay, so right about precession, number 6th point, right? The rate of precession is directly proportional to the applied torque. And inversely proportional to the moment of inertia and rotor RPM rate. Now, the formula for precession is actually very confusing for some students. Therefore, precession is directly proportional to torque and inversely proportional to rigidity, because inertia and RPM give you rigidity. T is equal to torque, R is equal to rigidity. Note, R is equal to IR, remember. Therefore, precession is directly proportional to torque and inversely proportional to IR. Both formulas are same. Jyotsna, do not panic. Hardik, Harsim, do not panic. Achal, do not panic. In case you find things difficult, you have just started. Relax, okay? You will reach a point where navigation will be very easy for you. So you just push yourself, learn as much as you can, and keep asking doubts. Keep your minds open. Now take a moment and make sure you are confirmed with rigidity and precession. Go through it, see if you have any doubts, go through your notes. Formula, there should not be any confusion. IR, what is I? Moment of inertia. Moment of inertia is based upon two things: radius and mass. So this R is not radius, this small r is rotor RPM. So here we will write I is equal to moment of inertia and R is equal to rotor RPM. And again, note, moment of inertia, that is I, is equal to mass and radius. Is directly proportional to mass and radius, you could say. Moment of inertia. And what do we do to keep the mass less? We concentrate all the major mass towards the rim of the rotor, rim of the gyro. Take a moment to go through it. अभी के अभी पढ़ लो ये चीज, बाद में के लिए नहीं रखनी है. You don't have to keep it for later. Study it right now only. It's basic. It's simple. Any questions? Can everybody see the screen? Can you see a gyro with gimbals? Nukul, please ask your question.
Sir, in cockpit, where the gyro is assembled, from where the precision will come, or from which component the precision will act to the gyro?
Are you saying how will precession affect the aircraft gyros?
Yes, sir. Sir, there is some source now that precision will act to the gyro.
See, precession is undesirable, okay? Precession is not desirable. So there is no source for precession. The source is for air pressure or suction to give the rotor the drive. Are you talking about source of precession? How we are applying precession to the gyro? We don't apply precession to the gyro.
No, sir, we don't apply, but we are studying here precession. It will act from anywhere, or there is a kind of source, minimum source will
First source
affect
is if the RPM is slow, if the RPM is not enough, then gravity is the cause behind precession. First reason is gravity. By natural, due to gravity, the gyro is always, for us, gyro is always doing this or this. Like, I'm sorry, I'm bad at acting, but the gyro instruments are always like this or like this. It will take any shape because of gravity. Okay, that gravity will apply torque. Otherwise, extreme maneuvers of the aircraft, extreme out of limit maneuvers can also affect the gyro and cause gimbal lock, or can affect can add precession also possibly. Otherwise, no other precession happens. Gyros are good. Precession happens, we are saying, but when you will do further reading, okay, it's not required for CPL, but when you'll go through the text for further reading, look out for what they say, what is happening when the aircraft is precessing, and due to precession, this happens or not. Here, I want you all to keep an eye. Look at how the spin axis is, how it spins. It spins towards me in the book, in the diagram. It spins towards you, it spins towards me. The torque is applied in the bottom. The torque is a load, so it's going down. And you see the hinges or the shaft of the rotor is attached to one ring inside. Can you see this ring? This is the inner gimbal or inner gimbal. And this inner gimbal is free to move both sides. And this inner gimbal is free to move on the outer gimbal here. You see why? Y-axis. This is the rotation given. Like this, to the outer gimbal. And inner gimbal is Z-axis. Inner gimbal will rotate like this or like this. Like this in circle. So two gimbals. So this one will give me yaw. This one will give me roll. And forward and behind will give me pitch. That's why two gimbals can give you three freedoms. Aircraft attitude will also affect. Precession can happen. Definitely. That's how we get indication. So when the aircraft longitudinal axis is going below the horizon or above the horizon, some sort of precession is affecting our rigidity, because of which we get the drift, because of which we get the indication that is angular measurement. Okay. And what is the frame? This semicircle is the frame, left side. This gyro is a table gyro for study purpose only, not the aircraft gyro. That's why they have a stand. And see, the force is going down. Because the force is going down, the torque is acting here. And because the torque is acting here, 90-degree direction of rotation is going inside the page. So here, this is where precession will act. And see this arrow they are showing. This is where precession will act. So it will shift the axis like this, like this. Take your time. Again and again, you read it, you will get it. See, torque applied, direction of rotation. So torque is applied here, torque is acting here. And in this direction of rotation, precession is happening here. Okay. Don't mind me using only one S in precession. Okay. In my notes, I've used just one S. Don't mind that error. This is drift, gyro axis. Drift, axis was here. Now the axis is here. This is topple, horizontal gyro, toppling, becoming vertical. This is vertical gyro that can topple any side. Vertical gyros don't drift. See, that is the spin axis, and there is one frame, or we can say this is the inner gimbal, one gimbal. Rotor, inner gimbal, outside frame. They all can move. Inner gimbal and outer gimbal can move, but rotor will remain stationary. Rigidity, right? This is your gyro compass, DGI, vertical card reader. See, this is the vane type gyro rotor. On these slots, we get air pressure or suction pressure. Your basic instruments have 3 gyros, basic 6 layout, artificial horizon, turn coordinator, and your DGI. This is your DGI. These are the 3 instruments which have gyros installed in them. Okay, remember, AH, also known as attitude indicator, DGI, also known as gyro compass, and turn coordinator with a slip indicator, slip and skid indicator. This ball is different, the tube is different, and the aircraft is different. 2 instruments in one. This is turn and slip. We'll come to it again. I'll be teaching you all the important gyros again. So these points I'll show you. So this is the turn and slip indicator. The aircraft bends in the turn and slip indicator, but in the artificial horizon, it doesn't turn. This is turn coordinator. It shows you whether your turn is balanced or not. While this here is your inclinometer showing you, as long as the ball is in the center, your turn is perfect. If the ball gets into the direction of your bend, then it's slip. If it goes away, it's skid. I'll teach that again. Okay, Mohammad Azam, anyhow, we are also wrapping up now. I'm just showing pictures. You can leave or you can wait for 5 minutes. It's okay. Even if you leave, it's okay. Okay, don't worry.
If it's 5 minutes, okay, sir, I'll manage.
5 minutes, yeah. Now see, vacuum pump. A pump that creates vacuum. So this is vacuum air filter. A filter is very important. In the overall video also, they talk about filter to give clean air. Vacuum is sent to the attitude indicator to run the rotor. This is a suction gauge showing you whether the suction pressure is enough or not. And it is also going in the DGI, directional gyro also. So these are pressure lines, suction lines, vacuum. So in a gyro that is air driven, the whole casing inside is full vacuum only, all vacuum. Because of vacuum. Why vacuum? Do you have any idea why vacuum and why not air pressure? Because in vacuum, the inner resistance will be 0. So we will achieve more RPM. See, this on the left side is vertical DGI, and this is the horizontal DGI. This is what we use these days with the airplane symbol instead of compass. Again, basic 6 type have 3 gyros, DGI, artificial horizon, turn coordinator, and slip indicator. This will read again when we do artificial horizon. This I'll show you again. See roll angles, pitch angles. This also we'll discuss again. See, this is an analog gyro instrument casing inside with a disc type rotor. They have showed the outer gimbal is the roll gimbal, while the inner gimbal is the pitch gimbal or gimbal, however you call it. That's it, students. Don't take load. Go through the notes that I have shared. PDF. Whoever doesn't have that email sent day before yesterday, please let me know. I'll share it with you. Okay. Stand by for next week's schedule. For this batch, we might change the timing. So I will notify you all. Okay. Whatever the changes are, Mohammad Azam, Nukul, Nandini, Manan, Subhojit, I'll let you know about this. And Hardik, Harsim, Jyotsna, Anchal, stand by for your next week's schedule. Okay. Over the weekend, you'll be given them. Given that, just make sure you go through these notes once that I have shared via email, and also go through the other text that I have shared that is from Oxford. All right, read that much at least. We'll continue with gyro in our next classes. I hope everybody attends. And Jyotsna, try to watch 46 and 45 before that. Hardik and Harsim and Achal, you also try to watch 46 and 45 if you have not watched it. It will really be helpful and keep you steps ahead. Okay. All right. I'll take your leave today. Short lecture. Enjoy your Friday. Enjoy your weekend. Anchal, good thing you have worked. You have watched it. I will send the notes right away to everyone once again. I'm not sure who has, who doesn't have. So I'll share it with everyone once again. I'll share it with everyone. Okay. Jyotsna, I'm sharing right now. I'll see you next week, students. Take care. Okay. Mohammad Azam, thanks for waiting.
Okay, sir. No problem.
Bye, everyone.
Bye, sir.
Thank
Go
you, sir.
enjoy. You're not going.
Thank you,
I
sir.
like students who don't leave the class. Come on, go. Come on. Chalo, bye, everyone.
Thank you, sir.
Thank you, sir.
Most welcome.